All right, Mark, thank you for being here again, talking about Machine Safety Workshop, part 2 of 5. The first one was amazing. I'm excited to hear what you have to talk about today. So I'm going to go ahead and shut off my video feed so you can be the center of attention, and the floor is yours.
All right, very good. So the last session we had last week, we talked about, the societal demands, and, really the output of those societal demands are laws and rules and regulations that are really to address the demands and what society is asking for. So we're going to get into that today. And once we get that, we'll start our journey down the machine safety life cycle, starting with risk assessments. We'll accomplish that. And you can see the rest of them there. We'll build on it from here. If you did miss any of these other ones, it's okay to jump into either one of these. Also, this is really a subset of I guess a honed down version of a full day machine safety workshop that we do for the region from as IMS. I'll come out and do this in person. It's much more bi-directional, conversational, when we do that. But online webinars, it's pretty tough to have broad conversations. But we're happy to kind of come out there at any time. So this is what we'll run through today, and we'll finish up with kicking off the aspect of the life cycle. There are some handouts that we handed out last week, the same ones for this week. If you don't know what this equation is, D plus V plus S greater than R, give me a call afterwards. I'm happy to explain it, but you've got a note sheet in there to kind of take notes. And if you have ideas as we're going through this presentation or subsequent ones, just jot some down into areas of dissatisfaction or visions you might have, or ideas of what steps you can take there, and then get an understanding of the resistance to change. So also the other handout is an overview of pretty much the whole workshop. It's the handout that we have for the workshop. And then there's some collateral about integrated mill systems, IMS, where I work for, controls integrator with machine safety expertise. Then you see the presentations in PDF form. So coincidentally, I'm just reading some about over Labor Day, some of the things that spurned Labor Day, and one of the articles was talking about a woman named Frances Perkins who witnessed the Triangle Shirt Factory fire in 1911. It sort of spurned the idea of worker safety, and she went on to become Secretary of Labor under FDR, and drove the Fair Labor Act of 1938. Established, essentially abolished child labor, and our 40-hour work week came from that, and first established on a minimum wage. But anyway, just, that was really all that was in place for quite a while. World War II hit, productivity became, aspects of national defense, and getting it out the door really trumped everything. So worker safety really kind of fell to the wayside, considering, these young boys in the theater of war dying, the fact that you're dying here in a factory, really sort of lost favor. Let's not worry about it. Let's get them the tanks and the guns we need, whatever. So anyway, so that's kind of set some, as I was reading this weekend, with Labor Day and stuff. So it made me think about this. But by and large, personal responsibility was really the means, really was the safety system, that existed for quite a while. And as OSHA was birthed in 1970, and those laws and rules began, to solidify those ideas that started, decades earlier, with this waistcoat factory. But from the time the Fair Labor Act was written, it was still 3 decades before specifics on worker safety were put into law. As you probably know, this is the general duty clause that was established in 1970 as part of the William Steiner Act and the establishment of OSHA, that everybody knows, and establishes the responsibility no longer as so much the employee's responsibility for safety, but established kind of the idea, the precedent, that employer is responsible for this. I highlight a couple of things on this, knowing that, a lot of us know and understand the first paragraph there, that each employer shall, and responsibilities there to provide a workplace free of recognized hazards. The second one, though, is also, there is still the responsibility of the employee, to follow these rules as well. So as we talk about what the rules and laws are and whatnot, it's a shared responsibility. We'll actually talk about, who's responsible for safety, and it's even, outlined in the standards here as well. But one of the other things I highlight out here is this word recognized hazards and what that means. There's sometimes a misconception that has perpetuated a myth out there. The myth is that if I'm ignorant of a hazard, then that's a viable defense. Ignorant of a hazard in my workplace. And it comes from this wording here, recognized hazard. Oh, if I haven't recognized it, if I'm not aware of it, then it must be okay. I don't, and actually I've had instances when I was in my previous career as a sales engineer for Rockwell, I was the Allen Bradley guy, but we get into the bowels of manufacturing. I remember walking through a factory, and I noticed something, and I pointed it out to the maintenance guy, and he was like, he was like mad at me. He's like, now I have to do something about it. He goes, why'd you tell me that? He goes, I was ignorant of that before, essentially, and I didn't have to do anything about it. But it's not really what that means. What recognized hazards basically is that an understanding that this can hurt you. And here's Maria Curie, shaking a vial of highly radioactive material, not recognizing that that was a hazard back then. But that's what this means. Smoking, even doctors recommended, people smoke and stuff years ago. But anyway, that's just to point out that if anybody ever says something, about, let's not do a risk assessment, or let's not, find our hazards and recognize them, or document them. Oh my gosh, as soon as we document them, now we have to do something about it. Well, you had to have done something about it all along. This is a myth. So we can chat more about that, later. But the Code of Federal Regulation 29, Part 1910 is where we find the laws, and these are sometimes referred to as the OSHA standards. And what they really are regulations or laws. The standards, we don't like to mix that term to say OSHA standards, because there's another form of standards. So we refer to these as regulations. They're really not standards, but they're incredibly vague. If you've ever read them, it really doesn't give you a whole lot to go on, other than you shall not, have things unguarded. There's a lot of specific, machine specific things for woodworking types of machinery and stuff that call out still kind of general, you shall guard it. That's all in subpart O. There's several subpart O chapters that get into machinery. These are the ones that are most applicable and generalized when we're talking about manufacturing equipment is 212 and 219. The other part is subpart J. Within there is where we find the lockout tagout laws, which surprisingly came very late in the game. 1989 was before that was actually put into law. So when it comes down to it, these are the laws on which we must be compliant. But the question here comes into is, how do we demonstrate compliance to these laws? So then we introduce another term of the voluntary standards. And really what that means is that I've got a multitude of standards about this specific topic in the law. I voluntarily decide on this one in particular. So for instance, and these are broken down in different types of standards that address different aspects of machine safety here. So there's assessments, there's product. So when you do a risk assessment, we follow ANSI B11.0. I'll talk more about that here at length at the latter part of this session. Companies that manufacture products that are safety rated, they'll have product types of safety ratings and standards to adhere to. There are the ways that these products that are then put together and combined and applied. And then there are performance aspects. Once I put a system together, we'll talk about this. We'll submit a whole session on the performance and validation of particularly machine safety circuits that were your light curtains and safety drives and all that good stuff. Right. So those are the types of standards that are out there. This is a list of what I would deem the core of a standards library. If you have a engineering department that has taken upon themselves to address machine safety, this is the machine safety core library. And the key ones in there, again, looking at risk assessments would be these two here. If I'm looking at the putting a whole system together, the performance of a system in there, B1119 is very recently, 2019 updated. It's a fantastic document as well. Here's where your lockout tagout rules and guides are from Z24244.1. If we're going to get into control circuits and machine safety circuits, then these are the standards that would dictate those. And then we can't forget about fluid power actuators out there, hydraulics and pneumatics, as well as, in addition to the electric motors, that are causing or could be the source of hazardous motion. So this is the core. Think about it as similar to like a law library. There's well over 1,000, close to 2,000 pages of standards just in these when you stack them all up. And the key to be an expert, most experts can spout off some line of verse of some aspect of these standards, but most of the time the key is where to find it. Just like in a law library, your lawyer or the paralegal or whatever knows where to find something in a law library, but it's quite extensive, and that's just a subset of what's available. So the other thing that the Williams-Steiner Act established with OSHA is its ability to enforce worker safety. So as you know, they can come in and inspect a facility, they do investigations, after an incident, and they can issue fines as well. So here's another myth, our second myth that we can dispel. A lot of times I'll deal with global multinational corporations that have facilities in Europe as well as the US. Asia and North America, Asian and Latin America and Africa typically follow the lead of Europe and North America. So they sort of reflect or gravitate to one or the other. So when we're talking about a comparison of societies, we typically talk about North America and Europe. One of the myths here is that in the United States, safety is the sole responsibility of the employer. And the reality is, though, it's actually the responsibility of not just the employer, but the supply chain as well, be it an integrator or a machine supplier as well. The difference is in Europe, all of this is covered in the criminal courts, right? All the concepts are highly regulated in the EU under the machinery directives that hold responsibility for machine safety, not just for users and employees, but also the supply chain. Now those, because there are specific laws associated with these four suppliers of stuff, in Europe, if there's an incident, they can be prosecuted through their criminal courts. So it seems like the government is behind, aspects of all four of these elements can be prosecuted through their legislated criminal courts. The difference in the U.S. is that we typically don't take these entities to court through criminal courts. They're typically done through civil courts, and our civil courts are extremely powerful. Any individual can sue anybody for any particular reason if they can feel like they can prove damages, and that's basically where this is done. So the enforcement and the litigation through all of this stuff is done through civil courts, which then by and large holds the integrators, holds the machine suppliers just as responsible, and sometimes even more responsible for machine safety here in North America as the criminal courts. So dispel the myth that, hey, it's all about the end user who's responsible for safety. The civil courts make sure that the machine suppliers, the OEMs, the integrators, the contractors are also just as responsible for that. So I can tell you some stories. As when I worked for Rockwell, I dealt a lot with our legal team there, and they'll tell you 99.9% of the time a safety incident gets prosecuted through the civil courts in North America. Even OSHA, because even though they're part of the legislated bodies, they will still use the civil courts to pursue some of that as well. So just some ideas. So the standards have provided some further guidance on this, and some of the latest revs of ANSI B11 standards will give you this sort of diagram to say essentially who is responsible and make this clear. Who should be doing this? And that's basically what the standards say. What should you be doing? What shall you do in order to be compliant? And you can see the 4 columns there. There's very little that the modifier, say the integrator or the contractor or the supplier is not responsible for. In fact, all of it, all the way down through the different scopes, phases of manufacturing and installing and integrating equipment. So there's some further guidance onto what kind of standards you can use to get those guidance for the modifier or the integrator. What standard would they use if we're in the conceptual side of a machine design and build. Okay, so essentially everybody's responsible for it. So there's nobody that gets out of this. So the compliance is demonstrated by adherence to these voluntary standards. So I elect to use ANSI B1119 to design my safety, my risk reduction measures, my guarding, for instance. I'm going to design it based on ANSI B1119. I show OSHA compliance, and I built this guard properly because I adhered to ANSI B1119. And there's details, I mean, down to the millimeter of how big that guard needs to be, where it needs to position, how far back it needs to go. And it goes on and on about, whether it's control circuits or lockout tagout. I adhere to ANSI Z244.1. That's how I show compliance. So to help keep some of these standards straight, and where do you start by looking at standards? There are different types of standards, and you start with the machine specific standards. So if there is a standard, and say an ANSI B11 standard that is specific to hydraulic presses, then there is a C standard for that, and you design the machine safeties around that. If a C standard doesn't exist, the B series or the B type standards will give you some, we'll call it generic, but they're concepts that are very detailed that can be used across multiple, not just the press, but a saw or a conveyor belt or something, unrelated to that type of application. And then you got the A standards are just kind of the foundational aspects. B11.0 is the risk assessment. Here's how you do a risk assessment, and that's applicable across the entire portfolio of machinery. In front of every ANSI B11 standard, you'll find a list of them, the current list. It's also very important, if you are going to adhere to a standard or state adherence to a standard, is that you include the year that of the rev that you're talking about. B1119 just was revved. It is really thick now. It grew by 40% in its latest rev because it added specificity, particularly around guarding and lockout, some of the lockout tagout references and trap key as well. So it grew quite a bit. So if you used an ANSI B1119 standard from the previous years, you probably aren't compliant today. So make sure you keep track of that. But here's a list of them as well. So all of that seems like, oh my gosh, I painted this picture of an elephant. How am I going to eat this? When it really comes down to, say, OSHA compliance, they really only have 2 rules when it comes around to safety around manufacturing. And rule number 1 is, and these are the foundational rules. These are the defaults that OSHA will expect you to turn off a machine. If access is required, you turn it off. And if machine is running, you keep people away from it. And we know those as lockout, tagout, and machine guarding. That is the foundational default when you get fined or cited for issues, these are the issues that will fall into these two categories: failure to lock out, tag out, or control hazardous energy. The other one is insufficient guarding, typically what you'll see. So here's kind of the flow through. Here's the subject, let's say control of hazardous energy. Here's the law of which I must be compliant to, and I can demonstrate that compliance through these particular voluntary standards that are written by independent entities. Usually the authors of all of this are our peers or safety experts from various companies and insurance groups or suppliers all get together in a committee and they write up these standards, keep them current. They review incidents that occurred despite the rev of a standard. Somebody can claim to say, I followed your standard and somebody still got hurt. So they'll study that and say, we need to revise it because we didn't think of the scenario. Revisions also are driven in these standards by advancements in technology and innovations of new products that are out there. You can imagine, when light curtains first came about, or safety PLCs, safety drives, there was a lot of conversation about how they used to do it. And now, hey, this new technology is available. Wow, what could we do? But let's do it in a careful manner. So control of hazardous energy and proper guarding are the two main ones. You see the third one down there. We're going to spend a whole bunch of time, I think, on the third or fourth session of this series. We'll talk about what's called the minor servicing exception. It's the exception to I'm not going to guard it, or I'm going to move the movable guard, or I'm not going to go through my normal lockout tagout procedure. I'm going to take the minor servicing exception. So there's a whole bunch of standards associated with that. How do you properly do that? For instance, use a control circuit instead of lockout tagout. Okay. So the other thing to simplify the whole view as well is that if you put all those standards together, you read through them, you get a full understanding of that 1,000+ pages of standards and all those books and whatnot. What you'll be able to formulate here is the ubiquitous machine safety life cycle. All of them, whether they're from International Standards Organization, the IEC, ANSI, RA, any of these organizations are all pointing to it, and they basically all say the same thing. They're contributing to these steps in the machine safety life cycle. And this whole series will take us around, obviously starting with risk assessments today, and we'll cover all of these in depth with enough depth for some understanding of it. This is a pitch integrated mill system, the IMS. I joined IMS about a year ago after over 30 years with Rockwell, sort of leading the safety efforts over there. But the IMS essentially follows that machine safety life cycle, and can offer services, support, engineering, and consultation around the entire thing. Okay. So those are the laws. Those are, the standards, how the laws and standards work together, to help you get to compliance. So the next step is the risk assessment. That's the first step in the machine safety life cycle. Typically, this would be the flow, right, of what we see. We're going to identify hazards. We're going to follow a systematic approach. But in reality, what typically happens if we're not doing a risk assessment, or traditionally, sort of what can happen is that we kind of crash through this thing. Somebody looks at it and says, wow, that looks dangerous, and immediately goes, well, I know how to fix that. We'll just put a light curtain on there, and then we'll install that and go, okay, that looks good, let's go. We're good. And that's typically what gets done, and there's some problems that come with that, and consequences of not doing or following the thorough standards-based risk assessment approach. The first one is really a false sense of safety. If that was not installed properly, if we didn't follow the standards and that have been well thought out to say, here's how far away that light curtain needs to be from the hazard, and stop time calculations, there's some real effort to go through to see, is it really safe or not? Maybe I made it worse. maybe the operators were much more cautious operating this machine, but now they see a light curtain on it and go like, oh, hey, it's safe. And they're a little more complacent, not as careful, but the safety system that was installed really isn't working to provide, adequate safety. So it can actually increase incidents. If a safeguard is put in or some sort of solution is put in that impedes productivity, a lot of times it can get defeated because it's impeding the real charter of why this organization exists, why that machine exists, is to get stuff out the door. So you do want to be careful about putting systems in that impede productivity. It should be, as we learned in the first session, the safest companies in the world refuse to accept or sacrifice safety or productivity. They will only accept a solution that will give them both. So it all starts with the risk assessment to try to understand it, because as part of the risk assessment, you'll see we'll start talking about, what to do about it, but we'll do it in a much more systematic way. Probably the key thing to this also, as well as you can read on there, is that the vast majority of safety incidents occur in non-normal operation. So it's during a jam, it's during something broke, something's misaligned or something, and somebody goes in and gets a quick fix to it. And that's when safety incidents typically occur. So the issue here with, when we come to what we talked about last session was that continuous dilemma of that operator making a decision between productivity and safety if the safety solution hasn't been designed to accommodate those properly. So we don't want a person to have to make decisions between productivity and safety. This whole safety system should allow for both. So specific to risk assessment, some guidance is to say, okay, when do we need to do a risk assessment? There's some myths in here too. One of the myths you may hear is this term grandfathering. And if you talk to any lawyer about hazards in a factory, and somebody makes the claim that, oh, hey, we haven't touched that machine since it was installed, it's grandfathered. That is a complete legal myth. There is no such thing as grandfathering. I'll show you some examples and why I think that's the case. When you look at your scenarios here listed here, when should I do a risk assessment? You'll see in the right-hand side here, perform a risk assessment in here, right? So I get in all of these scenarios, the standards will say, oh, yeah, it is a requirement to do a risk assessment, whether I'm modifying a machine or I'm putting in a new machine, or even if I move it, right? If I reconfigure it, if I put it someplace else, it's recommending that you do a risk assessment. The only exception to here, no risk assessment is required right here. Well, these are both two scenarios where I'm refurbishing, but the difference here is the utilization of comparable and non-comparable components. So here it gets into some interpretation and some subjectivity here. What is a comparable component? So in the IMS world here, a lot of times we will retrofit DC motors with AC motors. So we're going to put an AC variable frequency drive on it versus a variable speed DC drive and motor scenario. So the question is that comparable? Both are controlling the speed of a machine and the torque of the machine, but one is using different technology, AC current versus DC current. It could be argued, is that compatible or not? So, there's no answer for that other than, it's something to consider. And, the only question is, should I do a risk assessment or not? Here's the other thing that might push you over the top in these scenarios. I'm refurbishing a machine. No risk assessment is required if I'm using comparable components, as long as you can prove that at the time that machine was installed, that it was compatible or compliant. Sorry, did it comply with the laws and standards and rules at the time it was installed? So how do you prove that? You're going to have some sort of proof and evidence, some documentation to say I did a validation. So we see in the life cycle here, I do a validation to the functional requirement spec. The functional requirement spec is based on the risk assessment. So if you didn't do a risk assessment, a functional requirement spec and then validate that to that, that's really the only way you're going to prove that that you were compliant at the time. So if you can't prove that, you basically have to do a risk assessment. So there really isn't a scenario where the standards say, no, for sure, absolutely, no, you don't have to do a risk assessment here. Basically, it's saying you do a risk assessment anytime you're going to do anything to that machine. And you could even argue that you should do that on a periodic basis anyway. So when should, when should safety be addressed? And this is further guidance, and this may seem obvious, but this still happens today, is that, specifications for machinery or production lines go out to the supply chain, and it's really all about productivity and quality and throughput, what these specifications would entail, but safety a lot of time is not included in it. But this is, and we'll see when we get into risk reduction measures, that if we can design a safer machine and not have to fix or address hazards that are inherent in the design, let's design those out at the very beginning. So that's really what this is talking about. And at IMS here, I've actually done risk assessments on solid models of machines with recommendations back to the machine suppliers about changing the process or changing some mechanical aspect of the design of the machine. That's when all that can be done. That's when it's the least cost effective and least disruptive. But you also see that, a lot of collaboration between the users and the suppliers, throughout the whole process, from the time of the concept of the machine all the way to its commissioning and startup. So standards with risk assessments, the ubiquitous standard that's been out there for a long time is ISO 12100. That's a global standard, international standards organization that establishes, really the first time back in the early 90s, I believe was the first time that was published, about here's how you go about doing a risk assessment. And it's excellent. In North America here, we're fortunate to have an organization called the B11 Standards Organizations and their subsequent subcommittees. So what they do is publish standards that are really written to the North American market and written in a way that a North American audience can better understand. And a little commentary, if you read the European standards from IEC or ISO, they read very much like very smart engineering type people wrote those things for very smart engineering people to read them. So they're difficult to interpret. The ANSI standards go very far in writing these in a way in which they're in layman's terms that they can be read. In fact, there'll be one paragraph of detailed explanation, and then like 4 or 5 paragraphs off to the side for expounding on it with examples. So it's incredibly well written. So in North America, if a company has not adopted standards, IMS here would recommend the ANSI B11 series. The other good news that if somebody says, hey, be compliant, I want you to do a risk assessment, comply with ISO 12100, ANSI B11.0 has completely absorbed all of 12100 and has expounded on it beyond. So you can do an ANSI B11 type risk assessment and be compliant to ISO 12100. So the other thing about this too is that if you do hire a consultant and they say they will conduct a risk assessment, they're probably not going to conduct a risk assessment. What they're probably going to conduct is a hazard identification. Something very different. A formal team-based risk assessment would be something facilitated by a consultant that would involve a cross-functional team from machine operators, maintenance people, even sanitary people, cleaning people, as well as engineers and EHS professionals, all with a different perspective. But we would want to facilitate a risk assessment. You don't really conduct one. So just to be clear on that. Also to identify, essentially what you're trying to get down to is the individual person, tasks, steps in those tasks, and every hazard to it. We'll talk more about that here in a moment. But the point here too is that we also want to be cognizant of the life cycle of the machine as it's being done during commissioning, startup, decommissioning, or normal operations or non-normal operations. What mode are we in the machine? Is it in automatic mode, manual mode? Is it threading? Is it in cleaning mode? And then keeping track of all the hazards. So, it becomes a pretty sizable effort here to essentially identify hazards and all the people associated around it. The process is very clear as well. This is something that has been harmonized globally as well, that the steps that one goes through to conduct a risk assessment. And they are right here. So we'll talk about those here. We'll go through these step by step, and you'll see the process here as we go through it, but we'll follow that flow chart here on the right. The end game of what you're ultimately would end up with a formal risk assessment is some sort of Word document that will describe the scope of the machine and some of the engineering functions of the machine and whatnot, how the thing functions, identify all the people. The real meat of the risk assessment then would be the risk estimation table here, or risk scoring. In there, you'll see, as we'll cover this in a little more depth here, each one of these line items is a person, a task, a step in a task, and associated hazard with it. And those will be refined, throughout, the discussions with the team. Before the risk assessment even starts, we'll be gathering information about the machine, energy sources, safety incidents, whatnot, just the whole layout. Try to get a better understanding of what's been going on with this machine. What are the issues today? A lot of companies don't have up-to-date drawings and whatnot. So when that occurs, then there's probably an interview process that will go through to try to understand that, or tracing out wires or whatnot. But you'll try to understand the true functionality of the machine as well. That's followed by some further expounding on the information gathering is really try to determine, is this machine being run the way that the machine builder designed it to run? Are we staying within scope of be it environmental or speeds or whatnot? We'll also try to understand that, is this machine affected by the environment, temperatures or lighting, for instance, if you're using skylights and now, at night you don't have it, obviously. But, maintenance functions and all that stuff. So all of that would be gathered and studied to get a better understanding of it. This is just a cool little illustration of why the environmental aspects of the machine are important, or the way the machine is being run. So it's a difference in stopping. Typically with machine safety, it's really a lot of times it's about stopping it. So this just gives you some sort of illustration of, as you know, as you're driving in a car, it takes you longer to stop. So, if we're actually running that machine faster than we had intended, or the machine builder had intended, some of the safeties that they may have installed in there may not be adequate. So environmentally also has an impact as well. If we believe that there's a major difference between the way the machine functions in the wintertime versus the heat of the summer, we'll recommend a risk assessment in both of those environments. If we do it in the wintertime, we highly recommend things being done in the summertime too, because typically things get looser and they're harder to stop, or they run faster. So speeds may be increased and your calculations may run off. You can start two ways. One, you can start with all the people, or you can start with the hazards. At some point, what we're trying to get to is this is a line item in the risk assessment here. So where do you start? With the people and what they do, or the hazards? Sometimes it's easier to start with the hazards because there might be some repetitive aspects of it. Multiple people may come in contact with a hazard. So once you identify that hazard properly and formally, you can copy and paste it into multiple people's tasks in there. So finding hazards is probably the hardest thing to do. And I can almost guarantee you that there will be hazards that are missed. That's why the cyclical aspect or repetitive aspect of a risk assessment, that machine safety lifecycle is that risk assessments should be done on a periodic basis. It's even stated in the standards. That's all it says. You pick the period. It could be 20 years. It could be a week, or anything in between. But finding the hazards are tough. And some of them, they're not the obvious ones. The standards will give you a list of recommended or suggested hazards, some place to look. It's helpful to scan through those to say, oh yeah, hey, I forgot there's a laser on here, or hey, we got noise issues or temperature issues in here. So what you ultimately, trying to get to is the identification of all the hazards in here, which, as I mentioned, is pretty tough. Some of the times the hazards are not obvious. I use this illustration out of a couple of the B11 standards here. In running nips, we all know in running nip points are dangerous in here, but some of them are more obvious than others. So this just is some demonstration. This is the one obviously we all know, two rolls, swishing that hand, but there's hazards associated with all sorts of different speeds and stationary objects. So, continuing to kind of expand it to go, let's go beyond just the obvious ones as well. So once we identify all the hazards, then tracking the people, that's the most important, the next most important aspect as well. Everybody who's what's called associated with that machine or affected by that machine. So you can see people directly or even indirectly that use that machine or collaborate with that machine, even bystanders and whatnot, helpers, cleaning people, temporary workers. The trick is to find everybody who would be associated with that, even bystanders in there too. One safety professional was when he saw my list in here, he actually asked me to add sales personnel in there. He says, you would be surprised how many times, and this was in the metals industry, the metals person had to go out and get a sample of something. So he or she is going out there, and sometimes reaching into machines just to grab a piece of scrap or something like that too. And he told me about an unfortunate incident where they've got a salesperson missing all 4 digits on their non-dominant hand because he wouldn't wait for the operator to shut the machine down. He just reached in and sheared off his fingers. So also, last thing, consider the training and experience level of these people as well. So you may have a representative on your risk assessment team that's extremely experienced. It's helpful to have somebody that is new and inexperienced as well, because they may have a different look. They're new eyes on the machine, but they may be operating that machine slightly differently than the experienced person. Or you might have different machines or the same machine throughout the corporation. And I've seen this countless people operate those machines differently. So make sure you've got proper diversity and cover all of the ways that those machines are operating. Once you collect all of these, the person, task, step, hazard, each one of those becomes a line item which will be part of the discussion and subsequent aspects of the machine, the risk assessment process. So don't be surprised when you could have sometimes hundreds of, even on a very simple machine. I did a very simple machine recently with just 3 people working on it, and we had well over 50 line items on here with all the hazards and the tasks that these 3 people did around this machine. It was a hazardous machine. So we ended up with, a lot of things that we wanted to go address. So 1.2, you'll see the numbering on here. There'll be some sort of, this becomes a line item. If you're using some management system, safety management system in here, that's just another means of helping track this, document it, archive it. Hey, we had this risk aspect out here, this hazard, we mitigated it, and further, here's the archiving and evidence that you may need later in case issues come up. So now we get into the next part. So we've got our tasks and our people. We followed all that. Now we're going to what's called scoring it or estimating the risk in here too. A good friend of mine, colleague, he's from Florida. He made this list here, and he likes to talk about alligators in Florida, that they're comparing them to machines. So he uses this as an example of that experienced showman there doing this machine, collaborating with this hazardous machine here. We'll talk about the scenarios of what he faces. But first question is risk, and a lot of times I'll just throw this out to the audience and see what kind of answers we get. But you guys probably all know that risk is a combination of severity and probability. In machine safety, we also then sort of break down probability a little bit farther to for those two components there: frequency, exposure, and ability to avoid. Just to take some more into the reality. So again, we're going to be having open dialogue in our team-based risk assessment about this particular task here of this guy, putting his going nose to nose with an alligator here. We talk about that individual, and the severity. What would happen if that handler got bit? How severe would it be? And what's the probability? How often does he do this trick? Is he doing it daily? Is he doing it every hour? Do they have shows, or he's just doing it once a week? And if the alligator did go after him, would he be able to avoid it? Just want a little sidebar here, just some aspects about probability. And that the aspect about this is that it's not a binary, this absolutely will happen or this absolutely will not happen. It's always something in between. So it's expressed by some sort of percentage typically, but it's never 1 or it's never 0. It's something always in between. So I just want to bring that up, that we're talking about probability, that whatever we do isn't going to make something safe 100%. It's just going to lower the risk, the severity, or the probability. Okay. But ultimately what we want to get down to is some sort of rating, some sort of risk level in here. So it's like high, medium, or low, or some derivations of that are combinations of severity and probability. So we will talk through each one of these scenarios one by one and give it some risk scoring. We'll talk about it in a bit. One of the other little sidebars about perception. I've been in numerous efforts or conversations with team-based risk assessments where the operator is there, and the EHS professional is there, and an executive is there, and they all have different perceptions on what that person is doing. One will say, yeah, that would never happen, or that's not going to hurt that much, whatever. And then you get some different views. So it's based on their person's knowledge or experience of the machines and how close they are. So it really is an aspect of judgment. It's best to not move on from that until we have reached some sort of consensus that everybody agrees, okay, this is the severity or this is the probability. And we continue to talk that out. We don't put a clock on that to say, hey, we're only going to talk about this for 2 minutes. No, we're going to talk about it until we get consensus. It's about quality and doing the right thing. So just another cute aspect about perception here as well, just to kind of illustrate that people just have different views based on, how much does this affect me or, affect people that we love. So the other aspect about estimating risk is that this isn't always done. This is something that IMS does in our risk assessments, is that we will do it up to 3 different aspects of estimating risk. And this is based on the standards. B11.0 does state, I want to look at initial risk. And this is important because, and what initial risk is, I'm going to strip away all existing risk reduction measures or thoughts. So what is the underlying risk? What is that spinning blade or that crushing metal, rollers or whatever, what's underneath whatever's there. So let's strip all that away and see what should we be protecting against. Then the existing measures, we add all what's existing obviously there, and we score all that risk again to say, did it mitigate it to an acceptable level, or, what's our residual risk of what's existing there today? If we find that it's not acceptable, then we move on to the third one and we think of, hey, what could we do? What should we do? This is kind of back to, hey, we should probably put a light curtain in there. If we did that, what would be the residual risk? That's probably the extent of what you do at the risk assessment stage in terms of coming up with the solutions. And it could be more than one solution. It could be layers of solutions as well. If I did this, this, and this, now what do you think the risk would be? Then we score it once again. And again, you're trying to get to some sort of rating risk level in there as well. So that's what will be done. The standards have a multitude of ways to estimate risk. I'm going to go through this part here pretty quickly, but there's a number of terrific ways to go about this. The default one that we do here is based on the Robot Industry Association standard, RIA. TR 15.306 is this risk tree on the left, talks about severity and probability. There's another one we'll talk about briefly. We'll just kind of go through that. Those are for an HRN is hazard rating method is for companies that need a little more depth and granularity into it. So let me just show you how this works. It's the risk tree. You're probably familiar with it. Start with the severity. You pick S1, 2, or 3. Then you move on to exposure and then the ability to avoid, and you end up with that on the right. So this is the reason that this one is becoming pretty much a consensus standard across North America is its specificity and its ability to break indecision within these committees that are or risk assessment groups. Is that when they're arguing about severity or probability aspects of it, you go to these definitions, and basically severity in this case, and we'll go from S1. S1 means you got hurt, but you don't have to leave the plant. You're not going to lose, there's not a lost time incident. Usually first aid will cover it, and you're going to make a full recovery. S2 is you're probably going to the hospital. You're going to be off work, but you'll make a full recovery. Say a broken bone. S3 is that you're permanently changed, that you're going to lose not only work, but you may not return back the way you were. So it's amputations or chronic illness or death. So then exposure, you see 3 there, but there's really only 2. The prevented, but beyond prevented is, and you can only do the prevented once I've mitigated everything. Then I can claim a prevented exposure. But I'm doing something. High is that it's happening more than once a day, and low is that it's less than once a day or once a shift. And then the ability to avoid is a lot of studies of the speeds of machines, particularly robots, and how fast people can move, whether or not they're paying attention, and the path in which they avoid as well. That dictates whether what degree of ability to avoid. So again, you look at these definitions in here if things aren't clear. In the workshop that we do, we'll go through a scenario. We'll look at this machine. There's a video, multiple videos of this scenario, and we'll actually go about and go through a scoring exercise on this. So we end up with this poor gentleman up at the top of that bin helping to load logs off of a forklift into this death trap with spinning blades down there. It's a debarker. We don't have time today to go through that, but basically we'll go through and score this and determine that person, the risk of doing that job is very high. The other reason that the RIA standard is continuing to gain guidance is it's further guidance of once I've rated the risk level, it gives guidance as to what I'm going to do about it, how am I going to mitigate it, how am I going to reduce risk from here. So you can see if I've got a very high or medium, it says, you know what, I can't depend on humans, to mitigate this risk, which is really the difference here. I'm going to have to eliminate that hazard. I'm going to engineer some sort of solution to reduce that risk. Anything below that, I can use a combination of the stuff above, engineered solutions, and say PPE or warning signs or something like that. But it gives some further guidance as to, okay, here's what I'm going to do about it. And I'm trying to be compliant, so I'm going to follow these rules. And it really kind of takes some of the subjectivity and the decisions to say, you know what, I think I'm just going to give the guy gloves and be good with it. But I want to be compliant. It gives some teeth as to the direction in which we go. We're going to talk about control circuits at length. I think it's in the second or third or fourth session. But the chart on the right is very important in terms of if we are going to use a control circuit, it'll actually dictate the design based on the risk level. So again, here's specifically, I have control engineers here who are asked to put in a safety circuit, and they're going, okay, what performance level and what category, how do I design this thing? And it's a major difference between say a PLC and a PLD, category 2 or 3 or 4. You'll have a totally different circuit based on that. So it's all relegated based on, what did I come up with a score of my existing, risk level. The hazard rating number is, again, it's a probability and severity aspect of it, but it's a multiplication table. The interesting thing about this is that I can change any of these numbers in any of these tables. The other part about this, there is no standard that's associated with this. This was generated out of the UK oil industry after some safety incidents occurred, and they felt like they needed more granularity, more specificity, and some flexibility to increase or maybe even decrease or temper, the numbers that they come up with. But even the rating table down here, I can add as many levels as I want, and I can change these levels in here to say, what do I call low, medium, high, kind of high, really high, very high. I can change and name any of this stuff. So all of these this is all free form. I can change any of these factor numbers. So if companies feel like the risk trees are insufficient, too granular, too restricted, they could do something like that. But then again, we would do initial, existing, and future, along that same, but just use a different risk rating. Okay. So those are the two main ones. There's some simpler ones, some 2x2 or 4x4 matrices as well, that can help as well. So we've estimated risk. We have a level. The next step now is to come up with determine whether it's an acceptable level or not. That's the evaluation of it. And again, that's going to be something typically done maybe at a higher level. Sometimes lines are drawn in the sand to say, you know what, we want everything to be low or negligible. Anything above low, medium could be okay, but it's going to take the sign off of, say, the plant manager. If we end up, we've done everything we can and a residual risk is still high, that might take a vice president of operations to sign off and say, hey, that task, it's hazardous. We understand it. But basically, the really important part about this is to approach all of this, the risk evaluation and the risk estimating, to be consistent from incident or application, scenario to scenario. Don't change what we call medium, don't change what we call high, and don't evaluate high or medium. Have some sort of standard, consistent rule that we say that we follow, whether we're evaluating or estimating. Okay. And, we covered this before. What's an acceptable risk is really the key as to why there's such a variability out there from place to place. Some companies have hazardous operations in them. Some, they tolerate much less risk. But what's acceptable is completely up to the company. You'll have to answer for it if an incident occurs one way or another. But if you can show due diligence and documentation, and particularly show the documentation associated with the safety life cycle, in this scenario here, this case, hey, we did a formal risk assessment. We did maybe 3 of them over a period of 5 years. We assessed risk on this machine 3 times. Here's the documentation. Here's the results of the workers and the cross-functional team that said, here's the risk, here's the evaluation of it. We decided as a company, this is as good as we're gonna make this, or we have further work to do and set out a plan ahead. So that kind of gets us into the machine safety life cycle. We'll talk about what you do about all this stuff in detail in the subsequent, the next session, all of the different options that are available. How do I reduce risk? As I mentioned, throughout the session here, that we'll talk about circuits, as well, but you don't have to be an engineer. This isn't something that you're going to design safety engineering circuits or machine safety circuits, but I want to expose what a machine safety automation engineer goes through, just so you have an appreciation for what they would be doing and why was that circuit so expensive as well. Okay, so that's what we'll cover next time, and hopefully I got close to being on time, a little bit over, but that's about as fast as I can crank through this this section. So hopefully that wasn't too fast. And as always, Nick, Mike, if there's any questions, in the chat, if you guys, I'm here to hang on as long as you guys want to answer questions, or you guys can call me afterwards too. Go ahead. Oh, I think you're muted, Nick.
Yep, we did have one question in the chat, so I'll send this over to you. It says, when doing the initial risk assessment and determining the scoring, do you consider any existing control measures? Example, fixed guards in place.
Right. So that's where you separate them. So I do the initial risk, take those guards away, take everything away. What's the underlying hazard behind it? And the risk to it, exposure, avoidance, if that guard wasn't there, what's under there? Establish that first. Then in your mind's eye, now look at it with those guards on there and score that once again. And so the important part of it is to get that risk level, follow its same consistent measure to get the risk level, and then do a similar consistency with evaluating and determine, is it acceptable or not? And then,
so
then
basically
you move on to there. Yep.
So we're looking for a base level of what the equipment is stripped down, and then what controls we have in place. And then if we still don't see an acceptable level, what additional control measures we should put in place.
Yep.
How about, so let's talk a little quickly about new organizations to this process. I own a shop. I've been doing machining for 50 years. Dad owned it. I now own it. We've never done any of this. Is there a simple risk assessment form that we can start with to start this process to at least start moving in the right direction?
Yeah, the first place to start, and this is very common. You might have it might be a big company, you got a huge elephant to eat, and risk assessments are expensive. It can take a week or week and a half. It can be, thousands of dollars to do a formal risk assessment. You certainly don't want to do that on every asset in here. So one of the first things that you do is audit the facility. So go asset by asset, get an inventory of the assets that are in there, the machines, right, that are there, the production lines, and put them in one of three buckets. No issues or minimal issues. I have no concerns here. The second bucket is I have concerns here, but they don't seem to be, that important. Third bucket is these are my biggest concerns. This is the highest probability if I do have a safety incident, it's going to come from machines in that third bucket. So most of the time, it's uncanny sometimes how evenly distributed the assets are in a factory amongst those three. A lot of times it's evenly distributed, 1/3, 1/3, 1/3. The nice thing about doing an audit is that I can sort of set aside 2/3 of my factory and say, boy, that elephant just, was reduced significantly here. I've got the incidents. My incidents are most likely to come from this bucket here. But during the audit, it can help me prioritize within that third bucket as well to say, 1 through 10, I'm going to start here. Let's start with number 1. Let's do a risk assessment on that. And you may have enough machines in that number 1 bucket or that third bucket, where you really want to go. It might take you 2 or 3 years to do formal risk assessments and subsequent mitigation throughout the whole thing. The benefit of doing that and having that plan laid out over a 3-year period is that if an incident does occur on, say, one of those machines that you were going to address in year 3, that you can at least show OSHA some due diligence and some responsibility as an employer to say, we had planned to do this. It was just practically, we couldn't spend all that money at one shot. We don't have the resources to do it all. But I have a plan up here. What I've experienced is OSHA is very favorable to companies that have that mapped out in that plan, to the point where they would totally rescind any fines associated with a machine that's in a plan, but coming later. What they have done is say, let's accelerate your plan. We'll rescind this fine if you, instead of getting those done in 36 months, let's get it done in 29 months, that third bucket. But starting with an audit can help you prioritize amongst those 3 buckets, and then within each of those 3 buckets, where do I start and how do I eat this elephant, a bite at a time.
All right. Well, thank you so much for that. I know those are some of the base questions we get, and I'm sure we might get
Yep.
some more to come in throughout the day or the week as people digest all this information. Risk assessments are so important, and at least doing a priority list of what to work on and then chipping away at this can get you to where you need to be. So once again, thank you, Mark, so much. Great presentation. I am looking forward to week 3 of this. To our members, if you got questions or you need assistance, please reach out to Mark or myself. We're both available to answer questions and get you in the right direction to help you get where you need to be.